Hello, and welcome to chapter 36 of this Flutter course. In previous chapters, we've been working with our CRUD service quite a lot, and also we've been working with Firebase authentication. So far, we've stored the user-generated nodes inside the CRUD store, which we are backing with a SQLite database, and we've also made that CRUD service kind of aware of the currently logged in user. So when a user logs in, he or she can only see their own notes, and when that user logs out and another user logs in, then the previously created notes in the database aren't exposed to the new user. So we've taken care of all those, but we still have our notes only stored in a local storage. And from this chapter on, we're going to be working with actually moving away from storing the user data in a local database and instead going towards storing that inside Firebase. Now, when I was designing this course, I was thinking about how I can introduce more and more concepts to become a better software developer and a Flutter developer. And one of those absolutely crucial things was CRUD, create, read, update, and delete. And though Firebase is a good way of doing that, but Firebase removes quite a lot of the logic that you otherwise need to understand to become a better developer. So Firebase has abstracted away the concept of CRUD quite a lot, in that you work with data in the cloud and you don't really know how that is being populated and where that is being populated. So when I started designing the course, I thought maybe, okay, we could have a look at storing data locally first to get a good grip of CRUD. And then after that, now that we understand how CRUD works and how those operations are performed at a low level on a database level, then we can move away from it and go to a more abstract layer. So this was a choice that I made early on when designing this course. And it is definitely not like wasted time. You now know how to work with SQLite in your applications, and you will probably be using SQLite more and more as you go on in your Flutter development career. So I hope that you understand that we still have good use of SQLite, and we've understood that. But now it's time that we move away from our local storage and move to using Firebase instead. So I'm going to bring up the caption for the next section of this chapter, and that's that we're going to talk about Cloud Firestore. So if I bring up my notes and go to that URL that I've provided right there for you and bring it up here, and you can see here in here it says Firestore is a flexible, scalable, and NoSQL cloud database to store and sync data. The way it works, I mean, you can go actually to this link that I provided for you here, and it tells you about how you can actually add Cloud Firestore to your application. But I believe we've already done that. So if I bring our application also to the screen, increase the size, and we go to our pub/spec YAML, we look at our dependencies. We're at the moment using Firebase Core, Firebase Auth, and in here also tells you have to use Cloud Firestore. So let's go in here and we can see we've already dragged in Cloud Firestore from one of the absolute earliest chapters in this course. We've already added this dependency to our application, so you don't have to do this. But if you don't have Cloud Firestore added to your application, you may need to do that now by following the instructions in this link. And if you don't have it, it's probably because you've missed one of the early chapters in this course. So we're going to be using the Cloud Firestore in order to store user-generated data, and in this case, our nodes. Now, you may be familiar with SQL and NoSQL, but what I can explain Cloud Firestore is that you will have two concepts that you need to understand, which are called collections, and the other ones are documents. So whereas in traditional SQL storage, you will have hard dependencies, and every table, for instance, when we design our SQLite database, we actually have to design our tables with specific layouts inside the table. So we have different fields, we have foreign keys, etc. So that's like a typical SQL relational database. But when you go to NoSQL, for instance, Firestore, then things are more document based. So for those of you who are doing backend development, you already know about that, for instance. So if you're using SQLite, then things aren't document based as you would think. But when we go to Firestore, then you will have like a lot more looser data definition for your tables and for your documents basically. So one document inside the same collection can contain 2 fields, and the next document can contain 3 fields. So it's a lot more open the way it is created with Firestore. So for the entirety of this course, from this point on, we're going to be dependent on Firestore in order to store user-generated content, which are notes in our case. So let's now talk a little bit about production versus test mode. Firebase, Firestore, as you'll soon see, it has different ways of allowing you as a developer to interact with your database. So there is a thing called a test mode and another called a production mode. And in test mode, what it means is that as you're developing your application, which we are, for instance, at the moment, then you may need to, for instance, open up your database so that you can actually interact with it from your application without even authenticating a user, for instance. So even if a user is not authenticated, you can actually issue some commands toward Firestore in order to read data, delete data, and change data. So that's that's as you're developing your application while you're still working with your authentication. But remember, we've already nailed down the authentication, so you cannot actually end up in the notes view or the notes list view, which is embedded inside notes view, if you've forgotten about that. You cannot end up in there if you haven't authenticated and if you haven't verified your email address. So we know that in our case, we don't actually really need to use the test mode of our database with Firestore. We're kind of gonna immediately switch to production mode. And what production mode is, for instance, when you develop your Firestore database, as you'll soon see in this chapter as well, you will be able to add some more rules to the database so that unauthenticated access to the database is going to be denied. And this is the kind of like model that we're going to be using in the rest of the this course. And also almost at the end of this course, we're also going to add some more rules to our Firestore database so that we make it even more explicit who has access to what. Just know that there is a test mode and a production mode. Test mode is a bit looser in terms of security, but production mode is a little bit tighter. In that case, that it just tries to make sure that unauthenticated access to, for instance, the documents that a user doesn't have access to are going to be rejected. All right, I've just noticed, I've just mentioned a few things about rules, and you may be wondering about what these rules actually are and what they actually mean. So I've prepared the link here, so I'm going to see if I can actually open it on my computer as well so I can bring it to the screen. Here it is. Okay. So these are the rules that I was talking about. So you see, if you're, for instance, a backend developer like I am, you will also be very familiar with deploying your application. So if you're, for instance, a Django developer or Node.js with Express or whatever, or a Flask developer, then you are probably used to deploying your application to some sort of a cloud service. And then you will also be responsible for specifying how users can interact with your backend and what rules are applied on what cases. Firebase, since it is not like this traditional backend that you have to deploy yourself, since it is a product that's already there and it's deployed, it needs your help in order to understand its security rules. So as you can see, this is a typical Firebase Firestore configuration of a backend. And you can see in here, it says the service is the Firestore service and match these documents at these paths, and also only allow read and write if the user is authenticated. So if you're a Django developer, you already know about like requests. You also get that in Django. So request user will contain the currently logged in and authenticated user there. So that this is very similar to that. And I'm sorry if I'm talking a little bit about backend development. That's just because I'm trying to like make this connection for those of you who are backend developers and trying to learn about Firebase Firestore. If you're not a backend developer, just know that these security rules are there to help you. They're there to help you secure your database, because you see, the way we've actually generated our application. Let's go to the source code and have a look at it a little bit. And when we set up our Firebase with the Firebase CLI and Firestore CLI, there were some files that were generated for us automatically, and they were inside this Firebase option. So I'm going to open that for us here. And you can see some information in here. As you can see, for Android application, there's an API key, app ID, messaging sender ID, project ID, and storage bucket. If anybody gets hold of this information, as you now are going to get hold of this information by watching this course, you will actually be able to replicate this Firebase options.dart in your own application with my API key, app ID, and sender ID, and interact with the database that I'm in control of, even though you personally don't have access to that database, because that database is stored under my profile in Firebase console. So using this API key and app ID, you can interact with the database, and it is only the security it's only the authentication information or the authentication rules that I specify in my Firebase config that will then decide who has access to what. So don't worry also about this. I'm going to delete this Firebase project actually by the time this course is released. So I'm completely happy with this information being public and shown to you, just so you see what I actually mean. So just know that with various roles that we can define on our Firebase Firestore project, we can specify who has access to what and based on what rules. For instance, if the user is authenticated or if that user ID is actually present in that document's ID field, for instance. So something like that. Okay. Now what we're going to do is actually start creating a Firestore database for our project. So what I'm going to do in here is I'm going to bring up Safari and I'm going to go to console.firebase.com. So I suggest that you do the same thing. Change the screen layout a little bit here so you see my screen better. Excuse me. And then I'm going to go to our Minos Flutter project. So I suggest that you do the same thing for your application. All right. So when we end up here, then on the left-hand side, you'll see something called Firestore Database, and I want you to click there. And just ensure that you've selected the correct application in here as well. You may have quite a few, just like I do. Then what we'll need to do in here is just to say create database, okay? And as you can see, this is now the screen that may look a little bit scary, but it's completely fine. And you can see there are two different modes specified here, as we talked about, production mode, and then the other one is test mode. In production mode, the rules by excuse me, the rules by default are quite bad. As you can see in here, it says any document inside the database is unaccessible. So, or inaccessible. It says don't allow read or write because the condition is just false. So, and you can see it says all third-party reads and writes will be denied. But this is really not the this is not how we are going to set up our Firestore database. We, as I mentioned before, we are going to tighten this up quite a lot in the future, but not just right now. So I need you to go into start in test mode, and you'll get this absolutely beautiful message saying in the default security rules for test mode allows anyone with your database reference to view. And remember, database reference, I mentioned that's inside this Firebase option. So that's the reference they're talking about. Okay, so it may sound a little bit abstract, but it's really not that difficult to understand. So, and it says edit and delete all your database from all the data in your database for the next 30 days. So, okay. And you can see the rule that has been set up in here. It says allow read write if request time is less than blah blah blah. So it's opening up your database basically for 30 days. It's actually quite intelligent. It's pretty nice. Okay, so I need you to do that. And remember, we're going to tighten this up soon. Okay. And then you can see in here, it says allow, basically set up a location for where your data is going to be stored. Now, there may be some sort of like conflict of interest between like the legal portions of your business and also where you want to store your data and where you actually feel comfortable doing that. And GDPR definitely makes this even more complicated if you're living in Europe. So I mean, even if you're living abroad, GDPR makes things complicated. Some websites that are hosted in the US are still not accessible by users in the EU, and this makes things a little bit complicated. I'm basically in Sweden right now, so I prefer to use maybe a location that is has something to do with Europe, and I can see Europe West, while Sweden is kind of like in the middle. So I'm just going to use Europe West right now. But again, this isn't so significant right now. It could have some speed implications for your application depending on where the server actually is. So it's really good that Firebase is giving you the option to choose the location of your Firestore database. So you may want to read more about this, and you can press learn more in order to read more about this. But I'm just going to pick Europe West just because I believe it could make more sense for me since I am located in Sweden. So choose a location that makes sense for you and then press the enable button. Wow. That is an absolutely horrific looking loading screen. But that is, I mean, it's not even centered. So that's okay. Firebase, remember, we're using Firebase as a free service. So I just want to make sure that everybody understands. I'm very thankful for having Firebase because it's made life a lot easier for me, even though I can create my own backends, but I sometimes still prefer to use Firebase. So just because it's so easy to use. So thank you so much, anybody who's working on Firebase and providing us with free services. So let's have a look in here about in our rules. So let me increase the size of the screen like this, and perhaps also increase it like this so you see it better. Let me see if I can perhaps close the section to the left a little bit, and I probably could actually have done that. So I'm going to go back in here and press this button to close that section. All right. So what we need to do now is to, as the caption indicates, we're going to change the the security rules in our database and change it so that we allow read and write if the user is authenticated. Okay. So we make sure, as you can see, it says request auth is not null. So let's go ahead and change that. So I'm going to remove everything after request dot like this. And you can see it gives you access to auth path resource time method. So I'm just going to say auth is not null. Okay. So we can actually bring it to the same line as well if you want to. So after you've done that, you can say allow read write if request auth is not null. And that literally just means that people who are authenticated with our application and they have a valid Firebase user when they interact with the database are allowed to read from and write to the database. However, remember, this is database wide. At the moment, it says any document, and we still haven't talked about documents so much, but I'll tell you soon about that. But just imagine anything in your database can be read from and written to if the user is logged in. And that's not so secure, because that literally means that I as user one and you as user two have access to each other's documents. Okay. Even if the application itself is like segregating these two documents, saying that, oh, you're user one, I'm going to just give you user one's documents. But internally, as a Firebase user, given our current security rules, you will have access to my documents, even if the application is limiting your access. Just remember that. Okay. So after you've done that, I need you to please press the publish button. So as you can see, it says publish changes can take up to a minute to take effect. And that's all right, because we're going to actually take more than a minute before we jump into using these new rules in our application. So, okay, now let's talk about collections here. And I've prepared a link there. So let me see if I can find that link here as well. So as you can see in here, there is a good documentation that will talk a little bit about collections and documents, and you could go through this. But I'm not going to do that right now. But just so you know, here's the link at the bottom of the screen if you want to do that. I'm going to talk about collections personally, so you will understand it in my words. So at this point, what we need is just to go to our Firebase database, okay? And what you'll see is a screen that kind of looks like this. So it has your project name in here, and then there is a button called Start Collection, okay? Just imagine collection, as its name indicates, is a group of related objects. Objects could be, you could interpret them as tables, as you traditionally have in your relational databases, such as SQLite. So a collection, just imagine, for instance, if we say, what does our application do? Our application stores notes for all its users. So user A has notes, user B has notes, but user C may not have notes. So the only thing our application is storing in database right now is notes. So that could be its own collection. Okay, so we just create a collection called notes, and in that collection we're going to store all our notes. Okay, so every user is going to have their own notes. That's how we are going to do it in this course. However, you as a developer may just think, I'm going to do it differently. What I'm going to do is I'm going to create a new collection of notes for every user. So user A is going to have a collection called user A notes. User B is going to have user B notes. Or you may just create a collection with every user ID. So you remember we get a user identifier from Firebase. You may decide to create a collection for every user based on their user ID. Okay, that's fine. But if you're following along with this course, I strongly suggest actually you do it the way I'm doing, especially if it's the first time you're doing this. If you've done this before, you may just be comfortable with creating another type of collection. Then be my guest, please go ahead. But it might then be difficult for you later on to follow along with the course. Okay, so those are collections. So let's go ahead and tap the Start Collection button in here. As you can see in here, it says, okay, this collection is being created in the root path, and just give me an ID. And in here it says a collection set of documents that contain data. And in here it's storing a collection of users. But remember, we don't have to actually store users in our database. Firebase is already taking care of this. I actually believe this is a bad example that they provided to ask people to say example collection of users, because this kind of gives the idea to developers, oh, now I have to store my users here. But those users are already stored at the Firebase level, okay? So let's go ahead in here and just say we're storing notes, okay? We're just gonna say next. And you can see in here, now we're getting something called a document parent path notes, and then it says a document ID. A collection must contain at least one document. Cloud Firestore's unit of storage. Documents store your data as fields. Auto-generate a document ID or customize one if needed. Okay, so that brings us to what documents are. A document, you could look at it as if you know about SQL from before, if you followed along with what we've been creating, like when we looked at DB browser for SQLite, then we had these tables like user and notes. These are like the schemas of a document. So as you can see here, and here it says every note is created this way. It has an ID, it has a user ID, it has a text, is synced with cloud. Remember all those fields, and that's the schema. In the Firestore world, those are documents. So that entire note schema is one document, and every field in it, then it can have a data type. So those fields, you may know them as columns from before when we created our own tables. Okay, so if we go back into DB browser, you may not have this DB browser for SQLite open, and that's completely fine. We're not going to actually work with it right now. You may even have like tossed that database in the trash, and that's completely fine. I just want to show you this, that when we created this note table or the note document, then we had different fields. Remember ID, user ID, text, and those are the exact same things in here, okay? So if I go ahead and create a new console Firebase and have a look at, for instance, my other Firebase projects, I can see I have a Notes app, and you can here see that the way I had designed this in the beginning of this course is that I had a collection, and then every collection had documents in it that had text and then user ID. Okay, so that's what we're going to do in here. We're just going to say a field of text and it's type string and it has no value. Okay, and then we're going to add a new field in here and just call it user ID. Okay, and then in here it has no value either, and then a document ID that we're just gonna auto generate. Okay, so we just pretty much just created a new note, okay, with a random document ID, and it has a field of text and another field called user ID. Great. Then I need you to press the save button. And now you'll see here, we have our notes collection, and inside there we have a document that has these two fields, okay? So what you could do also is to delete either a collection or delete a document. So I'm just going to say delete document and start delete. And as you can see, now we have an empty collection called notes. I still find this a little bit peculiar that when we create a collection, Firebase forces us to create a document inside it. Like if I go and say start collection and then press the next button in here, I can't actually save my empty collection. And it says every, let's see here, a collection must contain at least one document. So I'm not sure if that's actually true, because you can see now we have a collection with no document. So I'm not sure why that was created, why that rule was set when you create a new collection, but just know that it's not completely true. So you can have a collection with no documents, all right? So now let's talk a little about streams of data. If you remember from our application if we go to our, I think it's called node service here, you remember that we have this stream of database nodes as a stream of list of database nodes, and we call it all nodes. In our application up to this point, we've had to manage these streams manually, in that we had to like go create a stream controller, do this whole dance of on listen, populate the stream controller with the nodes. You'd be really, really happy perhaps to hear that when we go to Firebase and Firestore, we don't have to do any of this, because Firestore already has all of this built in that when you, for instance, read all the documents inside this notes collection, that will actually be a stream of those data points for you. So no more stream controller and no more streams that you have to manage manually, okay? Those will be exposed to your application using Firestore. So as you saw, and when I created this collection to begin with, I created it with a note document that had a text and it had a user ID field. So our goal in this chapter and going forward is to make sure that every note has a text and it is actually linked to a Firebase user using that user's user ID, okay? So if we go to our application to our auth service. So let's go to auth and then auth service in here. And remember, we're using Firebase auth provider. So let's go in there, and you can see that when we say create user with email and password, for instance, then this function return something called user credential to us. And user credential actually has quite a few properties. You can see it has a credential and it has a user inside it of type user. So if we go into that user, you can see it has different properties like display name, email verified, metadata, phone number, etc. But this user also has something called a user's unique ID, which we actually need in order to store notes into our notes collection. So, and this is what I mean. Every document that we create is, for instance, going to be note some random ID or something, which we haven't decided yet. And one of the fields, let me actually see if I can resize this Safari window so you see it better. So it's going to have a text, and the text is going to be generated by the user, but it's going to also have a field called user ID. Okay, so in this user ID field, we actually need to store that user's Firebase generated ID in there. Okay, and Now, going back to what we are doing with that user, do you remember we're not actually exposing the Firebase user to our application, and that's a great level of abstraction. However, we have a little bit of a problem in that right now our user has email and is email verified. It doesn't actually have a unique ID. So our application is not going to be able to associate new notes with an auth user, is not going to be able to associate a new note with a user ID. Okay. So we need to fix that. So I'm just going to go to my notes a little bit in here. And what we need is to update our auth user, as you can see in here. So in auth user.dart file, as I've opened in here, what we need is to add a new field, which is a required field. And we need to make that the ID of that user. Okay. So let's go ahead and do that now. So I'm just going to go ahead and say final string and ID. So this field is not optional. You see, every user that comes into our application should have an ID, and that's like the expectation that we have on our auth users. Okay, so I need you to go ahead and add that, please, to your auth user class as well. Let's then go in here, and I'm going to add this to the required fields. I can see Visual Studio Code wasn't able to actually make this a required parameter. I'm going to help Visual Studio Code and do that. I'm just going to say required this ID, and I need you to do the same thing, please. So now we have a problem in here in that our auth user in here doesn't have an ID where we created from Firebase user. Let's go and remedy that. Let's just say the ID in here is the user UID. Remember this parameter that I talked to you about? Okay. So that is now created. And let me actually go to scrcpy. I can see that Visual Studio Code has a little bit of a problem hot reloading right now. So, and that's because probably the application wasn't in the foreground. So that's fixed now. Talking about scrcpy, it's perhaps a good idea for me to bring scrcpy here just to make sure that we're not breaking anything. Okay. So that's one change that we have to make to our auth user. The other change that we have to make is to make sure that the email parameter of our user is not optional. You see, the way we are creating at the moment our application is that we've created the login process of email and password authentication. So we don't have like Facebook authentication or Google authentication. We only have username and password. Email and password. So given that condition, we can be sure that every authenticated user in our application actually has an email address. Okay, so let's go ahead and just say that email is not an optional field anymore. And in here, we're going to explicitly unwrap that email. All right, so that's another change that we made to our application. So now that we've done that, you can see Flutter is not so happy with those changes, saying that, well, yeah, you broke something, and it's our tests that have been broken. So as you can see, we need to make sure that ID is actually included in our tests as well. And since we're not actually creating a specific test for that user ID, we can just add a random ID in here, which is say my ID. Okay, and I'm going to bring that and bring it down here as well. So we have an ID field in both cases of auth user inside our tests. Okay, now we have another problem, as you can see in the captions. In our create update node view, we're unwrapping the user's email, and that's what this little orange views folder is. It's not red, meaning that well, yeah, it's not an error, but it's a warning. So let's go to this create update node view and have a look at this field in here. As you can see, we're inside the create or get existing node, and we are unwrapping this email. But right now, the warning is saying, what is it saying? The asterisk will have no effect because the receiver can't be null. Try removing the asterisk operator, and I need you to do that, please. We have another problem also. We have another warning inside the notes view, and I believe we're doing something similar in the notes view. So let's see if we can find that warning. Where is the warning? I actually don't. Oh, here. we have the user email in here as well. So I'm just going to remove the asterisk after that. So I need you to do the same thing, please. Okay, now we're going to get to the juicy parts of the cloud storage integration. So I'm basically removing all the Dart tabs from here. I'm actually not deleting the files. I'm removing like the tabs, so it's a clean slate. Then what we need is to create all our cloud storage exceptions. You see, if you remember from when we worked with our CRUD service, which is a node service, then we also had a file under the CRUD folder called CRUD exceptions. And in here, we define all the different things that could go wrong when the user is working with our node service. Now that we're moving away from CRUD, we need to have our new exceptions defined somewhere. And as you can see in the caption, just like we had the CRUD exceptions, we're also going to have some exceptions thrown by our new Firestore service, which we haven't developed yet, but we need to define those exceptions at least, okay? So what we need now is to go and create that file. So I need you to please create a file under lib services cloud, and then create that file as cloud storage exceptions. So I'm going to do that as well. So let's see, I'm going to fold all the folders in here. So we have lib services and then cloud. You can see we don't have cloud at the moment. So we do have services and we have auth in there and CRUD. So I'm going to right click on services and say new file. And then in here, I'm just going to say cloud and then / cloud storage exceptions.dart. Okay. So after the creation of that file, I'm going to remove the Project Explorer there as well. What we need then is to define a superclass for all our cloud exceptions. If you remember from the CRUD exceptions that we created in here, all those exceptions were actually of type exception. And that's one way of doing that. However, if you want to group your exceptions under one super exception, you could then handle them quite smoothly, or better actually, I would say, at the call site. So that basically is going to use inheritance, and then we are going to create a new exception, as you can see here, called cloud storage exception, and all our cloud exceptions are going to be of that type. So makes grouping and catching these exceptions in the future a lot easier. Okay. So let's go ahead and create our first exception. It is called, I can see it's called cloud storage exception. So let's go ahead and say class cloud storage exception and implements exception. Okay. And we're also going to create a constant constructor for it. So it makes creating instance of this a lot easier. And you could also basically say that this is an immutable class, meaning that this class and all its subclasses need to be immutable. You could do that, all right? That's fine as well. But usually exceptions aren't marked with this. It's usually data classes that are marked with immutable. So I'm not going to do that right now. Okay, that thing is done. Now, so that's the parent exception. We should try not to throw that exception as it is. We have to throw subclasses of that exception, okay? Now, the first exception that we're going to define is could not create node exception, I believe it's called. Yes. And we're going to throw this in our to be written class soon upon you trying to create a new node. If Firebase Firestore is not able to actually create that node, then we're going to throw this error, okay? So I'm going to then define that exception, and you will need to type this then. I just brought it from my notes. Now, also in this screen where we have all the notes displayed for a given user, we may also not be able to retrieve all the notes for that user. For instance, if there is a network connection issue or whatever other issues that may arise. So we need to have an exception for that as well. And that exception is called could not get all notes exception, okay? So let's define that as well. And it's written just like could not get all notes exception. The next exception that we have to define is called could not update node. So we have create node exception, get node exception, and now we're on the U part of CRUD. So you see the create part is a C in CRUD, get is R, and now we're looking at U, okay? And that is could not update node exception. So we could say this is U in CRUD, and the get is R in CRUD, create is C in CRUD, okay? And so we have C, R, U, and then we have to define D, which is for delete in CRUD. And that's exactly what we're going to do now. So let's go define could not delete node exception. All right, so let's then say D in CRUD. Okay, so now we have four exceptions defined, and all of those exceptions are inheriting from cloud storage exception. Okay, now that we've talked about the exceptions, we also have to talk about the actual cloud storage service. You see, we have our CRUD service at the moment, which we've been working quite a lot with, and we're very proud of it. Actually, it's a lot of code. In my implementation, at least in here, we have about 360 lines of code. I mean, it's not all code. There's also spaces. There's like, I think there are some annotations like immutable, etc. But there's quite a lot of code, okay? And there's a print statement in here, which I actually have to remove, okay? So there's quite a lot of code. And this is working with SQLite, but we also need a service that works with Firebase Firestore. So we need to create that service soon. So just know that we are going to have CRUD in here, which is going to talk with SQLite, but we're moving actually away from it. So let's then fix that. So let's go in here and have a look at our constants. If you look at our node service in here, we have our constants in here. We have routes. And at the end of node service, we have some constants defined right in this class or right in this Dart file. And some people may like this, but I personally prefer to have my constants defined in separate files, even though these constants are very related only to this file. But just putting them in separate places just makes it easier to look at, because these constants at the moment are like hidden at the bottom, very bottom of this file. So let's go ahead and define our constants. So let's have a look at the path. It's going to be in services, cloud, and then cloud storage constants. On the services, now we have cloud, and under cloud, we have cloud storage exceptions, I think, exceptions. Yep. Now we have to define cloud storage constants. So new file, cloud storage constants, Dart. And I'm going to go to my notes, constants. All right. Now, if you remember from our node service, we define like the tables and, excuse me, and we define the tables, the columns, and even the format of creating new tables. We don't really need these. All we need are these two fields, as you remember, the text, and also we need a field for user ID, like this. So let's define these. Let's just say owner user ID. So let's go in here and say const, increase the size, owner user ID is just user ID like this. And then we're going to say const text field name. Excuse me. So I need you to define these two fields as well for your application. Okay. So let's go back to the original font size in there. So now that we've defined that, if you remember from our node service, we had these beautiful classes in here, called a database node and a database user. Now, given that we're moving away from storing things and nodes inside the SQLite database, and we're moving towards a Firestore databases, we actually don't need a database user anymore. But we do need some sort of a class that represents these documents that we're going to create in here, okay? And what we are going to call that is called a cloud node. So let's go ahead. You see here it's called a database node. So then you kind of know that this is a local database maybe. You could rename this to local database node if you want to, but I'm not going to do that simply because we're moving away from this. So what's the point of refactoring it? So I'm going to close node service. So then let's go ahead and create a new file called cloud node dart under services, lib services cloud. And I'm going to call it cloud underscore node.dart. In here, now what we need to do is to actually implement cloud nodes. Excuse me. So what a cloud node actually is going to contain, there are 3 properties that the cloud node has to contain. And they're namely the actual identifier of that node. And I apologize, I actually have to put myself into do not disturb. So there are 3 things a cloud node has to contain. One is the actual primary key of that node in our database. Every document that is generated by Firebase is going to have a unique ID. If you're coming from backend development, then you're already familiar with this. For instance, Django has this idea of a PK, which is primary key. You can also read it as ID. So everything that's stored in a database has some sort of a primary key. Firestore is no different. So every document that is created inside a Firestore database is also going to have a primary key, okay? So that's the first property that our cloud node is going to contain. The other 2 are very familiar because you saw here in the documents, we're going to have a text field, and the other one is the owner user ID. So there are 3 fields that we have to add to our class. So let's go ahead and do that. Let's just say, if I can type here, so class, sorry, I have a microphone right in front of my face, it's blocking my keyboard. So that's why I have to look like this just to find my keyboard. So let's say cloud node. And inside our cloud node, let's define these 3 properties. So let's just say final string document ID. Okay. And I'm going to copy the string here as well and say owner user ID. And then we're going to say text. Okay. Help from Visual Studio Code to implement the constructor. And in here, then I'm going to say this is a constant constructor, okay? As I said, you could actually go and define this as immutable, which I actually prefer in this case, to be honest with you. I hadn't planned to make this immutable, but I think it actually makes sense. If it's a cloud node, then let's just say it's immutable, okay? So that's the first part. And I also know that we need to make these required parameters. So let's go ahead and do that. Let's just say required before all of these parameters, okay, so that they're actually required named parameters that are not optional, basically. Okay, that's that. If you look at how our database node, let's see if we can find database node inside nodes service. So let's have a look at database node. Do you remember that we had these fields, but we're pretty much never calling this database nodes constructor. We're always using this thing, database node from row. And this is basically the object. You see, this map is the object that we're reading from our SQLite database. And then we're internally creating instances of our database node from that object, okay? So this kind of map is what you will also receive from Firestore. However, it's going to be wrapped inside something called a query document snapshot. So it's just a wrapper around your data. So let's go ahead in here, and what we're going to say is, if you just type query document snapshot, then Visual Studio Code is going to import this automatically for you. Okay, so poof, then it should be imported in here. So that's great. And also we need our cloud storage constants. So let's go and import those as well. So let's just say package, my nodes, and we have, what do we have? Where is this stored? Inside services cloud. So services cloud constant, or sorry, cloud storage constant. So You need Cloud Firestore Dart and then your constants as well. But let's go ahead and create kind of like a constructor that we are going to call from snapshot. And this constructor is going to allow Firestore to give us a snapshot of a cloud node. And then we're going to create an instance of our cloud node from that. Okay, so let's just say cloud node from snapshot. And the parameter is going to be query document snapshot that has that map that we actually need, like this, and we're going to call it snapshot like that. Okay, so now you can see that we're getting some errors from Dart saying all final variables need to be initialized and a function body must be provided. Okay, we're going to fix this soon. So this is the signature of your function. Then in here, your job now is to make sure that all your fields are initialized. So let's just say, if I can type again, document ID comes from our snapshot ID. That's a property that is stored on this at the snapshot level, so you can get that ID. Okay. And what we're going to say is that we have an owner user ID that we also have to fill in. So that comes from the snapshot, snapshot.data. And in there, then we have to say the owner user ID field name. Let's see, owner user ID. Owner user ID, let's call this field name. So sorry about that. Let's go back to the cloud storage constants and fix this to say owner user ID field name, actually. Okay. So we missed that, but that's okay. It's just a naming change. So then we're going to say owner user ID field name. So that's for the owner user ID. And then we're going to get the text, which is equal to snapshot.data, a text field name as string. Okay, so what we have is a beautiful cloud node immutable class with a constant constructor, and also we get this snapshot query document snapshot from Firestore soon, and we can create instances of our cloud nodes, as you'll soon see. All right, now what we need is to create our new Cloud Firestore service. So this is like the beginning of moving away from CRUD storage into Firestore. So this is actually very exciting and a little bit intimidating maybe at first, because, well, we kind of have to like redo quite a lot of work. But given that Firestore provides you with pretty much all the tools that you need, as you'll soon see, the implementations of the functions that we're gonna do are so minimal because the base is there. Firestore has already provided the base. We just have to hook into it and grab the data, write the data, etc. So let's close all these tabs that we have at the moment. Excuse me, and let's go to this services cloud and create our new Firebase Cloud Storage Dart file. Firebase Cloud Storage Dart. All right, so I'm actually going to do that as well. So Firebase Cloud Storage in my notes. All right. So let's go ahead and say we have a new class called Firebase Cloud Storage, like that. And at the moment, it doesn't do really anything. But what we need to do is to make this a shared instance. And I'm going to bring the caption for that. And if you remember, we've already made our node service a singleton. So let's go back to our node service, Command P on Macintosh and Visual Studio Code, or Control P in Windows and Linux to bring up this search files by name field. And I'm just going to say node service. If you remember inside node service, I think at the top we had this pattern for creating a singleton. Do you remember this? Right? So we kind of need, this part, we kind of need the same thing. Not kind of, actually pretty much exactly the same thing, except for this part, because this talks with a stream controller. So I find this pattern of creating singletons in Dart still quite hacky. I think I've mentioned this before when we created the node service, but it's something that we have to do. So make sure our Firebase Cloud Storage is actually a singleton, okay? So I'm going to bring that code from my notes because I don't think it's actually worth writing this. It's not worth your time or my time, but this is what you need to create. So what is happening in here is that we have a private constructor. Then we're going to create a factory constructor, which is the default constructor of our class, Firebase Cloud Storage right here. And that is going to talk with a static final field, which in turn calls this private initializer. So in other languages like Swift and Rust, it's a lot easier to create a singleton. But this is a pattern you have to do. So first create a private constructor, then create a factory constructor that talks with a static final, which in turn talks with the private constructor. Okay. Okay, after you've taken care of that, what we need to do is to grab all our notes from our cloud storage. Okay, so let's just go ahead. After this factory constructor, we're gonna expose a field as the caption at the bottom of the screen indicates, called notes. So I'm just gonna say notes equal to, we're just going to say Firebase and Firestore, and it's going to auto import it for me. So this is not a strange thing anymore to you as well. And then I'm just going to say our own instance, and then, excuse me, a collection called notes, single quotes as well. Okay. So this is how you actually talk with Firestore. So you can see that the signature of this collection is actually returning you something called a collection reference. And you will soon see how we can extract our actual notes from this collection. All right. And also remember, this isn't going to work if you haven't actually created your notes collection. So if you haven't done that, if you forgot to do that, please go ahead. Excuse me, to go ahead and do that right now. So the first thing we need to do is to create a function for creating new notes. All right. Excuse me. So let's go ahead into our project and create a function as the caption indicates. I'm going to say void create new notes in here. And then we're going to say we need an owner ID. So required string owner user ID, I believe we call it. And then it's an async function. Okay. And then in here, since you have like a stream of a read write stream of all your nodes, and that's what this collection reference means. It's not only a stream that you can read from, but also is a stream you can write to. That's why it's not called a stream, okay? Because a stream is like you try to read only from it. So, and in here, what we're gonna do is gonna say notes add, and you can see it literally says, give me a map or a dictionary or however you want to call it, an object that has keys and values. What do you want me to store in a database? And that's what NoSQL kind of means in here, is document based. It has no real structure of what you're adding. Everything that you add in here is going to be packaged into a document that is going to be stored in here with the fields and the values that you specified in here. Okay. So let's go ahead and say we provide you with a document in here. And the first field is owner user ID field name. And that's going to auto import it from our constants from before, remember? And in here, the value of this is going to be the owner user ID. And the text field name is just going to be an empty note for now. Okay, and remember, this is an asynchronous function which returns a future of a document reference, just like we have our collection reference in here, but we actually don't want its result right now, at least. So we're just going to await on it. So don't forget the await, because without doing the await, this function is not actually going to be invoked. Wow, okay. What we need to do now then is to go to the next item. Excuse me, which is getting notes by user ID. So the signature is going to return an iterable of cloud note given a user ID. So as we said, every note we store in our database is going to have these two fields, an owner and a text field. So now what we want is to grab all the notes for a specific user. Okay, so let's go ahead and do that. So it's called get notes, and it's quite a meaty function, actually, I can see in here. So let's go ahead and do that right now. So let's say future of iterable of cloud nodes. And I think we have to import cloud node as well. So pressing this button imports it for me. If you're getting some errors, it's probably because your editor hasn't been able to find cloud nodes. So, and then we're going to say get nodes and a required parameter in here, owner user ID. Okay. And it's an asynchronous function. So like that. So what we're going to do then is to await on our notes in here. You see, we can actually retrieve notes from our notes collection in here by saying notes where. So we're going to do a search inside the notes collection reference, and you do that using the where clause. Okay. And these things could actually create an exception. I believe the where clause could actually throw an exception, whether it was this one. It's not documented in here, but I do believe that it could actually create an exception. So let's go ahead and catch this. So let's just say try. We're going to try. And then should anything happen in here, we're just going to throw could not get all nodes exception. And this is going to auto import that from our previous code. So I shouldn't explain this over and over again. You know already how that works. Okay. So now that we have that, we have a try and catch statement in there. So let's just say we await on nodes and we say where clause, and the where clause is going to say, okay, what is the field that you want to do your where search on? And we want to search for all nodes that are for this owner user ID. So let's just say owner user ID field name should be equal to, you see, that's the parameter, is equal to owner user ID, like that. Okay. After waiting on it, you see, sorry, after doing a where, this gives you a query, but then you need to actually execute this query, and you do that using its get function. And you see it returns, let me see, get, if I move my mouse over, you see it returns a future of a query snapshot with all the objects that Firestore could retrieve from the database. Okay. So we have that get. What we do then is to do then. That's how we work with future. So a then clause of a future allows you to return it. What it does is it returns the value of that future to you, and it allows you to return either a synchronous value inside the then function, or you could actually return another future. Those who are familiar with Node.js or just JavaScript in general, or even Swift, they're familiar with how promises and how futures work. So this is your chance of actually returning a value given this future that is returned to you. Okay. So we're going to call this basically value at the moment. And if I move my mouse over this, you can see it says a query snapshot of these potentially read documents. So in here, what we're going to do is say docs, which is all the documents that could be read. And we're going to map all those. And you can see in here, if I call this doc, if I move my mouse over, it says a query document snapshot, whereas this one was a query snapshot. This one is a query document snapshot of those fields. Okay. So let's go in here. And what we're going to do is to say we return inside this, return a cloud node. And we have these three fields. Okay. We have the document ID, owner user ID, and the text. So it's our chance basically to create an instance of our cloud node right now. I'm going to put the colons here so we get the formatting a little bit better. Now what we need to do is to get the document ID. And the way to do that is this doc has an ID in here. You can see it's a string. So, and the other one is to the doc, and then we have the data. And let's just say owner user ID field name. And that's a string. And in here, we're going to say then doc data. And we say text field name as a string. Now, remember, this looks very familiar. Where have we done this before? Yeah, we've done this in Cloud Notes from Snapshot. And don't worry, we're actually going to use that function, and soon we're going to remove this return statement the way it's written. But let's just write it like this right now, okay? So it's easier to understand. Wow. All right. I think that should be it. So we have that. Excuse me. And yeah, I believe this is going to cover it for us right now. So not much more to explain about this, to be honest. So we could also put a comma here to make the code a little bit more readable, and we have the value, then return. And what we don't have, to be honest with you, here is this return statement in here. Or actually, we created this like this. So yeah, it's an arrow function, so we don't have to have a special return statement. But if you don't like this kind of an arrow function, you can grab your code that you've written up to this point, like this, and create curly brackets in here, and instead use this syntax to say return instead. Okay, so it kind of depends on what you prefer. I don't have a preference, and I could use an arrow function the way it is, so I'm just going to leave it like this. Okay. And remember, we're at the moment awaiting on this, but we're not returning it. So let's just return it. So this is all basically just a fancy way of us, excuse me, communicating with Firebase Firestore and reading documents. And there's so much to explain that I can't go through all of these, but I really suggest that you play with these functions yourself, read the documentations, and see why is it that I'm using where and then get. So for that, you need to read all the documentations that come with these functions so you understand them better. Okay, so that's getting notes by user ID. Now, what we need is also um, the ability for us to be able to provide our notes list in here with a stream of notes for that particular user. Okay, so as you know now, in our notes service, the way we have it is we are exposing this stream of list of database note, and that's what we kind of also need to do with our Firebase Cloud Storage, like have a function that our notes list excuse me, can subscribe to and read all the available notes for that given user. So let's go ahead and do that. Let's just call it then a stream iterable. And I have that function signature, so I don't think I should actually write it manually, but you may need to write it. So that's a function signature, okay? And in here, what we're going to say is that we're going to go to our notes collection in here and get all the available snapshots. Let's see, we have our notes, and then we have our snapshots. And we're going to map that. Let's just say, yep. And we're going to get our documents inside that snapshot. And then we're going to map that like that. And let's just call it doc. And in here, we're going to create a cloud note from snapshots of that doc like that. And then in here, we're then going to say where. That's our note. And then we're going to say the notes owner user ID. I'm going to actually write this, and then I'm going to tell you what I'm basically doing, because there's quite a lot of code in here, and like pausing to describe every little bit of this code could actually make it look more complicated than it is. So I'm just going to then say owner user ID. Okay. Put a semicolon there. Wait a minute. This ends there, and then a semicolon there. Yeah. So let's see what is happening in here. So this looks actually quite intimidating to look at, but it's a very simple piece of code. So what we're doing in here is, if you want to grab a stream of data as it is evolving, you want to be able to subscribe to all the changes happening to it, then you need to use something called a snapshot. As you can see, this is a stream of query snapshot, whereas where is a query itself. Okay, and then get is a future. So it just, the get one literally takes a snapshot at that point in time and returns it to you. But if you want to like keep hold of, like if you want to be updated about all the changes live as they're happening to your data in the notes collection, then you need to subscribe to this snapshots. That's what we're doing. Okay, so that's that first part with snapshots. So we're literally saying that we want to see all the changes as they're happening live. Okay, then it says, okay, I will give you all the changes that are happening live, and that comes inside a query snapshot. Remember query snapshot from here? Remember query here? Inside the get. So after this point, it's literally what we did in the get notes. It's saying that, okay, here is a query snapshot. And then we're saying, okay, there are documents in there. And that's exactly what we were doing in here. There's documents in the query snapshot. And then we're mapping every document to a cloud note. All right. And then we're putting a where clause at the end that says we're only interested in nodes whose owner user ID is the owner user ID provided in here. So without this where clause, we're literally exposing all the nodes to the current user for all users in the system. So that where clause is very important. Okay. So, and this where clause, as you can see, it is actually inside Flutter bin lib core iterable. So that's nothing that it's not a function that Firestore has provided for us. Okay. Wow, that was a lot of information. Okay, let's go ahead and talk about updating new nodes. Updating existing nodes. So as we talked about it before, if you have a node and you tap on it, the way it works in our application right now is that I can tap on this node and go and change its text like 22 and come back out, and now it's changed to 22. Okay, so we need to also expose this functionality. Excuse me. Inside our Firebase cloud storage as well. So the function is going to be update node, and it's going to take two parameters, document ID and a text. So let's just say it's going to be a future of void, and we're going to call it update node. Two parameters in here which are required. And I'm going to say required string and document ID, and then required string text. And let's make this an async function. All right, then what we're going to do is we're going to put a try and catch in here in case we can't update the nodes. And in here, we're just going to say throw could not update node exception, okay? And you may actually ignore this E if you want to as well. So you could just do like this, or you could just, yeah, I think actually we can't do an empty catch. So you may do it like this if you prefer, but I prefer to do it like this. All right, and I can see that the formatting is a little bit messed up in here, so I'm going to put a comma in there. And inside the try statement in here now, what we need to do is to go to our collections again in here, and let's just say we get a doc. You can see it says, okay, what is the path of that doc? And we're going to say the document ID is the path. And then let's then go ahead and say dot update. And it says, okay, what is the actual update? And inside the update, what we're going to do is going to say text field name is this text. All right. So this may look a little bit cryptic. Now also we have to wait on it. This may look a little bit cryptic in the what is doc ID. Remember, inside this function in here, it says, give me the path. You see this parameter path? And what we said is that inside the notes collection, every document is going to have an identifier. So we actually are going to go with the document ID, which we instantiated in here. Do you remember? Doc ID is going to go into our cloud node document ID. So that's the path, is notes / that document ID. So that's how Firebase Firestore basically keeps hold of its paths. It's the path is, in this case, if I create a collection, see it says, oh, the collection is being created in the root folder, and it has a collection ID, which in our case is called notes, and we refer to it here. So we've already constructed the notes path, and every document inside it has its own ID. So it's going to be /notes / document ID. All right. So I hope that explained it for you. Let's now talk about deleting notes. So deleting notes is actually very easy as well. So we don't have to do so much with deleting notes. So it's very similar to updating notes. And we're just going to go ahead and use document ID for deleting notes. So as the caption indicates, create a new feature of void in here. And we're going to say delete node. And we're going to go ahead and use a required string parameter called document ID. Async, and let's just do a try catch in here in case we can't delete the document. And then we're going to say throw could not delete notes exception, I believe it's called. Yep. Inside the try statement in here, we are going to say notes, doc with that document ID. All right. And then we're just going to say delete. And remember, I believe this is actually future avoid. So let's just await on it. All right. So that's really all you have to do for delete. So there's no magic in that. It's very similar to update note, except that it's not taking care of any like fields or anything like that. Wow, huge chapter. We've talked a lot about now about Firestore and Firebase storage. So thank you so much for sticking with me throughout this chapter. And but if you remember, I mean, if you look at what we've done, is not so much code. Is 68 lines of code for me. It may be less for you if you haven't done all these extra commas in here. So it may be like 60. But there's a lot of new concepts. So I thought that I took the liberty of maybe even over explaining things. But I think in the beginning it's very important just to understand how everything works. Okay, so great job. We've done what we promised to do in this chapter. We haven't actually tested to make sure that this is working. We're going to do this in the next chapter. But as is tradition, we're going to make sure that our work is committed to our GitHub repository or Bitbucket, wherever you're using your, wherever you're hosting your Git project. So let's go ahead and do that. I want to change the screen layout a little bit. Going to get rid of scrcpy. Oops. And I'm going to close the screen, make this bigger in this view, and then I'm going to go to terminal. Okay. Excuse me. Let's have a look at our status. There's quite a bit modified in here, and also we've added a whole new folder. So I'm just going to say git add all. And let's have a look at our log. The previous commit was step 18, and let's have a look at our tags. I can see step 18 here as well. Let's commit now, and let's say step 19. Excuse me again. And then we have commits, and we've committed, and let's push those changes. Let's also tag and say step 19 in here, okay? And let's push our tags as well. All right, that's that. As again is tradition, at the end of every chapter, we talk about what we have to discuss in the next chapter. And as you can see, it says we need to start using our new service instead of SQLite database. So that's a little bit of a like a turning point in our whole course, in that we're gonna like toss our local storage and go away from that and start using our Firebase cloud storage. So it's I think the next chapter is actually one of the most exciting chapters, excuse me, in this whole course. So grab some refreshments if you want to, and I'll see you there.